Okay, so good morning or good afternoon, everyone, and welcome to today's webinar, how MEP is changing eSIM and why tracing is now critical. Hello, also Andras.
Hi, welcome everyone.
Okay, so here you can see a quick overview about what we will cover today. So we will start with the question, what is MEP actually? Then we will talk about the MEP testing aspects. Andras will then do a live tracing with an MEP device. And in the end, we will discuss an outlook, so the MEP use case in the future. And of course, we will finish our session with a dedicated Q&A session.
Okay, let me introduce myself. My name is András Tálas. I'm a technical consultant in Comprion. I'm mainly involved in standardization activities around GSMA, TCA, global platform, and mainly in the topic of eSIM.
Okay, so my name is Laura Strunz. I work in the sales team at Comprion here in the headquarter in Paderborn. So we are a Germany-based company. So for those who don't know us yet, Comprion is a test tool provider for different industries like the automotive, IoT, or telecommunication. But today we really want to focus on the MEP feature. So if you have any other questions regarding our portfolio or whatever, please feel free to get in touch with us after the webinar. And yeah, let's talk about the housekeeping. So you are all muted and you are not able to chat, but you have a question button, and we really recommend, we highly appreciate if you raise questions. You can do this during the webinar, and in the end, we will hopefully answer all your questions. After the webinar, we will share the recording, we will share the slides, and of course, the Q&A session separately. So you have also the option to join via LinkedIn. There you have no question button, but you can use the live chat to raise a question. Okay, and I think we can start. So Andras, what is MEP?
Yeah, what is the MEP? So the MEP is a buzzword which stands for multiple enabled profile. And basically it means that the MEP capable device allows two eSIM profiles to be active simultaneously. Then the user can control under which profile, which subscription, which services he wants to run. MEP from standardization point of view is one of the most sought after features in SGP22 version 3. And regarding the coverage from the real devices, there are already several devices supporting MEP, among them iPhones and Google Pixel devices. The main use cases. So we have listed here 3 use cases. One of the major use case is same as with the dual SIM devices, basically using the same phone for private and business purposes. MEP makes it possible also to optimize the cost by using separate subscription for data and voice. And the third use case is also a very typical one, which enables you seamless connectivity during traveling and optimizing the data cost by using separate description for data and separate description for voice. After the main use cases, some thoughts about why we think that tracing is critical for MEP. So when we say tracing, we are saying that the APDU data stream, which is between the SIM and the modem, is traced by a tool. And the tracing has the benefit that the data stream from both profiles can be visualized. Why this is good? Because we can check if profile management operations like enabling, disabling are executed properly. Also, we can check if specific APDU commands like verify PIN are sent on the right channel. We can take a look at the authentication between the SIM card and the network, if this is properly done. And also we can see if the network preferences from the profiles are taken into account. The challenges which we as test tool providers see in MEP testing is that the MEP implementations are existing in different variants, MEP A1, MEP A2, and MEP B, and the test tool has to support all these different variants. The MEP testing approaches currently available are basically three. One is the EUICC conformance testing. It ensures that the MEP is implemented in accordance to the GSMA SGP22 specification, and this is by running SGP23 test cases for EUICC. This is currently governed this activity by global platform. Second aspect is the device conformance testing. The same focus, the device implemented according to GSMA SGP22 and running SGP23 test cases. This is governed by GCF and PTCRB organizations. And the third approach is the end-to-end testing. This is important because the real complexity emerges in the interaction of the components during an actual operation. So this is not about specification compliance, but this is about real-world behavior while the phone is used. So the compliance to GSMA specification alone is not enough. The real challenge, just as mentioned, is how the multiple eSIM profiles, the mobile network and the device interacts during different processes, like adding or removing profiles, or how the service behaves after one profile is deactivated. There is no standardized specification for these processes, but the validating is possible, and we will show you one approach, what we Comprion implemented. This is a tool which we call eSIM tracer, and this tool enables to visualize the communication between the cellular module and the EUICC or eSIM. In the next part, I'm going to show you some traces, some light traces using a Google Pixel phone and the eSIM tracer. So I'm changing my screen. On the right side, you can see the Google Pixel 9 phone UI, the SIMs. So there are several SIMs installed on this Google Pixel phone. And on the left-hand side, you can see the eSIM tracer tool. In the eSIM tracer, in the separate lines, you can see the APDU commands, which are exchanged between the EUICC and the device modem. What properties are shown is the source on which channel, on which slot the communication is executed, the command itself, the status of the command, and the command APDU and the response APDU. So currently the commands are all the status commands which are sent in the idle mode of the device on different slots, slot 0, 1 and slot 1, 0. I clear all these interactions now, and I'm going to the device, and I'm enabling first the Vodafone profile, which is a real-life profile, and I turn it on. And on the left-hand side, on the eSIM tracer, you can see the APDUs exchanged. Now the screen on the mobile device has been blacked out because I need to give my PIN. After the SIM is unlocked, the tracing continues, and I go back to the beginning just to take a look at a few APDU commands. So the first interesting thing is the select ESDR and the store data. The store data is the command, sorry, this is a one more down. Store data is a command which contains the enabling process. and the select ASDR and the store data is sent on the same channel, slot 1.0, and it indicates that this phone is using the MEP communication variant. So after the profile is enabled, the refresh command is sent, and then several APDUs are read from the SIM, like the MEP, the ICC-ID. You can see here the ICC-ID, the preferred language, and if I scroll down, we can see here the selection of the IMSI, but the reading of the IMSI fails because the PIN has not been verified yet. Let me see the verified PIN. Command, here it succeeds, and after the verified PIN, the IMSI can be now successfully read, and you can see here in the translation window that the IMSI content is also translated, the MCC, the MNC, and the MSIN. There are several other files are read during the enabling process, like the UST, where all the services which are supported are given and indicated, HPLMN. Yeah, and another important command which we can see is the authenticate. And you can see that the authenticate command is also sent, and this is successful. Now I'm going to enable the second profile. And after some questions like labeling the SIM and setting the primary SIMs for services, the enabling starts. We can see here that the communication, most of the communication is happening on slot 01 compared to the previous profile, which was on 1.0. And if I go back to the beginning, we can see here also few important communication. Like selection of the ASDR and the successful enabling of the profile, then the refresh command, and then all the APDUs which are selecting and reading the EF content from the second profile. This is happening on slot 01. So the enabling process of both profiles are successful. Let me show you what happens when we enable and disable the airplane mode. I'm just clearing now all these screens and clicking on the airplane mode on and the airplane mode off. Making the slot also visible. And the most important command which is exchanged here is the authenticate command, which means a new authentication to the network. And you can see that both profiles on slot 1.0 and on slot 0.1 are authenticated to the network successfully. Finally, let me show you a third APDU stream, which is recorded by me during the idle session of the device. So this is a log which I'm loading. During an idle session, several status commands are exchanged on both slots. And what we can also see, several envelope commands. If I'm opening this command, we can see that these are location status information commands. These envelope commands are exchanged on both slots. And this is basically the device is informing the SIM card that there is a location update happening. Besides envelope command, another typical command which is exchanged in idle state is the fetch command. If we take at the timestamps, we can see that basically in every 25 minutes, there is a fetch command sent to the device, and I'm choosing one. After the fetch command, you can see that the terminal response with the device location information is again sent to the SIM card. So basically, these are the communication processes which happening between an eSIM and the modem, and where we can see the multiple enabled profiles working properly. After this, I would like to take a look at the new emerging use cases of an MEP device. We have listed here 3, but there are also more. One of them is MEP opening up a long-term possibility for more granular control of services. For example, the internet traffic could run over public networks, while the security critical or enterprise-specific applications such as VPN connections are routed through private networks. We are expecting the extension of MEP in the context of GSMA eSIM for IoT specification, SGP32, and we are expecting MEP in the automotive use cases. One of them is the navigation via OEM profile and, for example, music via driver profile, or using the best of the multiple available networks, for example, for autonomous driving. So after this part, let me give back the presentation role for Laura.
Thank you, Andras. So before we wrap up, let's move to the Q&A session. So just a reminder here, we already received some questions during the webinar. If you have not yet typed in your question, please feel free to just click on the question button and send us your question. If you are joining on LinkedIn, please feel free to use the live chat. Okay, so Andras, what are the typical use cases for MEP in IoT?
Yeah, so maybe the most typical use case is the automotive use case, which we just mentioned, using different services for with different profiles, like music or video in a private profile and the OEM specific profile for navigation. Another use case is the autonomous driving, where probably having a critical service, selecting the best profile with the best coverage would be useful. So these are just 2 examples.
Okay, thank you very much. So the next question, is there any potential overlap between the tracing functionalities shown here and those enabled by entitlement service? What are the benefits of each approach?
So this is something which I cannot answer now, but let me give some time and I will try to answer it offline.
Okay, thank you. Sounds good. So next question. Is it possible to trace the power up process?
The power-up process is not possible to trace because the eSIM tracer needs to connect to the device and it cannot connect only after the device has been set up, some communication also with the card. But the enabling and disabling of an eSIM card already shows you very similar processes to the power off, power on, not containing the ATR and the PPS, but containing several other traces for the eSIM, for the EF reading.
Okay, thank you. And can you see the content of the profile with the tool?
The profile content cannot be seen because that one is sent encrypted. And this is also a possible approach from the modem manufacturer that it also obfuscates those APDUs which contains the profile.
Okay, thank you very much. So maybe again a short reminder, if you have any questions, please feel free to raise your question. Now you have the opportunity. If not, if you have any questions after this webinar, please feel also free to reach out to us. So, are the SDK comments also translated?
Yes, the SDK comments, several of them, like terminal capabilities, terminal profile is translated, and we are adding new SDK commands also in the coming releases.
Okay. And is the tool supporting all the new devices on the market? And what are the limitations?
Yes, so several of the new devices are supported. I would say the majority of the new devices are supported. Currently, support for Qualcomm chipsets are covered in almost 100%. MediaTek chipsets are also covered. iPhone is covered, and Samsung chipsets, which are in Google Pixel phones. But for example, from Apple, not all the new devices are covered, only some selected ones. And the same is true for MediaTek chipsets. So it depends on the chipset manufacturer.
Okay, so there is a limitation, but not on our side, so on the chipset side.
Yes, yeah.
Okay. Then, if there is no new question, I would say we can close this session. So thank you very much, all of you, for joining the webinar. Andras, maybe you want to say a few words?
I also thank you for your attention. In case you have questions, you can ask from us also directly in the presentation, which will be shared after the webinar. You can find the email contact. Yes, and yeah, see you in the next webinar.
Thank you very much.